Hello, good morning. Thank you for having us. I'm Doug. This is Kristen. I'm going to speak to you about a project that involved a lot of technology and allowed us to do a bunch of cool things. There were a lot of challenges to surveying this project. We got to use a lot of digital technology. We spent a lot of time on 3D workflow. Was important for the project. And then coming out of this project, we started thinking about ways to do things a little differently in the future. So I'm going to give a little background and then pass it on to Kristen from Vertical Access, who was a big partner for us. The background to the project is that the Soldiers and Sailors Memorial, which is located in Manhattan, in New York City, is owned by the Department of Parks and was in need of a full condition assessment, and they turned to New York City, the Office of Management and Budget, and Perkins Eastman Architect had a prime contract with them, and we were on their team, and they asked us to put together a team that could do a full condition assessment and also a restoration treatment study for the future to try to understand the magnitude of what would be needed to fully restore the monument and the memorial, actually. So we led a team of Vertical Access, GBG, and other consultants to do the assessment. Access to the site is actually very difficult. We'll talk about that a little bit, but first a little background on the monument. It's actually a memorial, soldiers and sailors, built turn of the century. Architects were Charles and Arthur Staunton. It's a classic monument, Corinthian temple style. It has a high base, it has a colonnade, it has a low conical roof. It's a central part of Memorial Day celebrations in New York City ever since. It actually houses quite a prominent location. It's in Riverside Park on 89th Street. It actually is built on top of a natural rock outcropping in the park. So at 89th Street, you're actually quite high. And so it's very prominent. It's a New York City landmark. It's surprisingly how much it's used, even though if you walk by on a regular day, you may not see a lot of people. It's an important monument to New York City. Despite that, they did not invest in it too much over the years. New York City, as many know, has grown, and Manhattan has the coastline has been extended with fill. But fortunately, even though tree growth has, Parks Department has allowed trees to grow in Riverside Park, it's still quite prominent from any location. So to give you a sense of what the monument itself is, and the talk today really is about the monument. There's the memorial includes a series of plazas and staircases that surround it, but the monument was the critical thing because of its height and the fact that the public can go around it and ideally inside of it. You can see it's actually it's a series of masonry walls with exterior stone cladding. The base is granite. There's a lot of marble. There's marble in the interior chamber as well. So basically you walk up a series of steps and you walk inside through a bronze door and you look up. And what you see is, and you'll get a better sense of this photographically from Kristen's talk, you'll see a Gaustavino vault that's an oculus, there's an opening inside. It has mosaic on the soffit. And then as you rise up, you can't really perceive what's on the sides above, but there's another Gaustavino vault at the very top that's mosaic as well. So there are some openings that let light in, so it's actually quite beautiful when you come in. We were very fortunate that Parks Department did have drawings. They had drawings from the original 1900 construction, not a complete set. We actually did not have good drawings of the monument itself, but we had the original drawings for the plaza and the esplanade. There was a major restoration in 1960, and we did have a drawing set associated with that. We did a lot of archival research, a lot of photographs, a lot of anecdotal evidence in the newspapers. And the thing we learned quite quickly was the minute it was opened and put in use, it had problems. It was leaking. And they described the masonry as sweating, and we had a mortar joint falling out. So for many years, it's been a problem. In fact, so much so that late 1950s actually had to temporarily close it, as you see there. The other important fact was that many of the symptoms we saw in the photographs and documented in the newspapers, we saw when we did our survey. So the same thing was happening all over again. So Parks, or New York City, did a major restoration campaign in the early 60s. They redid the entire series of plazas. They actually, the roof, the conical roof, the finial, has marble slabs. They actually put lead sheets on top of that. They removed some interior drainage and did a complete masonry restoration. In that slide on the upper right, you see a bit of what the site looks like. Basically, you enter from 89th Street right here, and these upper plazas are quite narrow, and there are staircases that go down the slope of Riverside Park. So with that, oops, wrong direction. I'm going to turn it over to Kristen to talk about how we actually surveyed this.
Yeah, so Doug just gave a really nice, succinct description of some of the challenges with this site, and the biggest one was access. So you can see that on these plazas, there's a very narrow area that goes around the monument, and what that meant was that with a lift, you really could have only gotten access to about 25% of the exterior. There are no ladders on the exterior, nothing on the interior, no hatch to get out on the roof. So really it was figuring out how to get onto the monument from the outside in. So we did bring a lift onto the plaza, and that allowed us to install some rigging at the roof in order to use rope access. And so that's what you see here in this image. And having the anchors at the top of the roof and then hanging the ropes on there allowed people to climb the ropes up from the plaza level. Usually we like to, go out onto a roof and then use gravity to our advantage instead of having to fight against it, but it didn't happen in this case. So our anchors then consisted of encircling the finial at the top of the roof with padded anchor ropes, and we did build a custom ramp to bring that lift up onto the plaza. And we were very careful not to overload it or damage the plaza in any way. So this approach allowed vertical access and other rope access technicians to observe all of the areas of the exterior and get hands-on to most of it. The areas, once you get down past where the columns are, we didn't get hands-on to that interior wall, but we got pretty good visual on the entire structure. And this avoided impacts to the plaza, avoided having to install tiebacks for scaffolding, and also was a minimal visual impact to the monument during the inspection because, as Doug said, it's a really prominent location. There's a ton of people around in the park all the time. And so this also allowed other team members from GB Geotechnics, who are rope access certified, to get onto the structure to do some ground penetrating radar as well as ultrasonic pulse velocity testing. And then access was also a problem at the interior where, again, there were no interior ladders, and we couldn't get to that space that Doug described that's above the lower dome with the oculus, but below the upper Guastavino tile dome. So in order to avoid having to build scaffolding at the interior, which would have been costly and better suited to full restoration work later on, we flew our drone through that 5-foot diameter oculus with a very skilled pilot. And we were able to gather both video and infrared imagery of the that interior space, which you really can't see from below because of the geometry of the oculus. Let's see. Sorry. So going back to the other challenge of the survey, which was collecting and managing all of this data, it's not a huge building, but there was a lot going on, and it was really important to gather comprehensive information about all of the existing conditions in order to start diagnosing the causes and what the potential solutions would be. So rope access really is just our means of getting where we need to be on the building, and then it's the tools and the technologies that we can leverage on rope that are really what helps us start to understand the structure. So this very thorough documentation of existing conditions was required here at Soldiers and Sailors, and in order to do that, we used direct-to-digital documentation. So this is an example of one of the photographs that we took where our documentation system automatically renames the photos with the numerical prefix is the XY coordinate where it's located on the drawing, the material, the condition, the failed Dutchman, and the year, and that's all customizable with whatever kind of information you need to have in that photo name. And then our deliverable included over 1,800 digital photos keyed to over 1,000 annotations on the exterior elevation. So the system that we use to digitally document conditions on site is called TPAS, the Tablet PC Annotation System. And Vertical Access developed this as an add-on that runs within AutoCAD. It's a proprietary software that we have. And basically each annotation is a database entry where as you're surveying, you're prompted to enter any number of data fields about the condition, describing the amount, the severity. You could assign a repair, and that's totally customizable in terms of what kind of data you need to gather about each individual condition. So this vastly reduces the amount of time that we spend in the office preparing a report, eliminates transcription errors. It's a way to make sure that everyone on site who's doing the inspection is sort of using the same nomenclature, and that's something that we work out with our clients before we get to the site. What are their data capture needs, and how can we customize the system in order to achieve that? So this means that there were 1,700 or 1,000 annotations that we didn't have to transcribe from paper into digital, and almost 1,900 photos that we didn't have to manually rename or come up with a system for naming those photos. And then using the drawing in a digital format lets you really focus in on different conditions by isolating different layers. So right here we just see all of the crack conditions, so we can start to identify some patterns and maybe some causes of the damage. And Kate said yesterday that they started using Revit when their clients started to demand it. So right now we're still working in a two-dimensional AutoCAD environment, but I think pretty shortly, maybe within the year, we're going to see some of our clients start asking for TPAS deliverables in three-dimensional format. So we have a plan for how we're going to make that happen. So stay tuned for that. And then all of the data that's embedded in these annotations, which are basically database entries, are exportable to AutoCAD, and you can start to sort the data. You can assign repairs based on certain criteria and whatever you really need to do. And then the background drawings for this survey were prepared by Lyra based on those the existing drawings, which were pretty good but not complete, as Doug said. And then several non-destructive evaluation methods were also used to confirm the subsurface conditions that were observed at the exterior and the interior. So ground penetrating radar that you saw those two GBG folks doing to confirm or help to identify embedded metal. And then they also did some ultrasonic pulse velocity testing to assess the internal integrity of some of the masonry units. GBG did infrared on the exterior from the bucket of the lift, and again, they were only able to do that on about 25% of the exterior because of the limitations of the plaza. And this is where using a drone would have been really an ideal platform for getting the infrared data. And if you've done infrared, you know that you want to have as close to a 90-degree or straight-on angle of view as possible in order to get the best data. So, standing on the ground and looking up at something tall, you're not really going to get usable infrared data. So this monument is located in controlled airspace, and it was prior to, or just after, we were on site just after those Part 107 rules went into effect, so we weren't able to request an airspace authorization in time to use the drone on the exterior. But the FAA does not regulate interior space. So just as rope access is how we get onto the building, how we physically get to where we need to go, the drone is really just a tripod, and it's the payload that matters. And our first drone, a DJI Phantom 2, was mounted with a GoPro camera on a motorized gimbal, and both of those were sold separately. The newer DJI models have an integral camera, as John mentioned, and shoot really nice video. There it goes, right through the Oculus. And so now we have eyes on this interior space that I guess there were a few photographs from the 1960s, but we also really needed to see this space in order to see what the condition was of it now. You can see some of the cracks through the brick masonry and some of the materials that were left up there after the last restoration. And then we also mounted a FLIR View Pro camera on the drone, which is a camera made by FLIR that's meant to be carried by a drone. It's very small. And we used that to get infrared imagery of the interior. We scheduled it after pretty heavy rain in order to increase the chances that we would see some thermal differences in the masonry due to water infiltration. And we did see cooler thermal responses at the joints, which was consistent with the failed mortar that was observed at the exterior and the interior. One lesson learned here is that a lot of this technology, both the drones and even the program Pix4D that we use, I'll talk about in a second, some of it is really developed for precision agriculture or larger site surveys. So the infrared camera is factory set to focus at infinity, which works as long as you're about 15 feet away from whatever you're looking at. But inside this pretty narrow interior space, we couldn't always maintain that distance. So we did end up with some infrared images that were a little too blurry to be very useful. And then something that we didn't use here, but that John gave a good idea of using, you're using Pix4D also, it looked like. So this is just another option for using photogrammetry where we take photos from the drone and then they're stitched together into a pretty good model that we can use to create an ortho image that can then be traced in AutoCAD. And for us, we see this as a great potential for getting really good background drawings for our TPAS surveys. So we were lucky on this project that Lyra made very, very nice drawings showing joint lines and showing a lot of detail. And that's important because when we are using TPAS, if you draw a box or you draw in a crack, the software automatically calculates the area or the length. And so in order to get really good, accurate data out of the survey, it's important to have a really good, accurate drawing, especially if it's a masonry structure or a terracotta clad structure, something where there's any chance that you might be looking at replacing entire units. If you can visually see that, where the joint lines are, then it's much easier to make those decisions in terms of conservation. So I'll give it back to Doug for some of the 3D workflows.
So one of the other things we were asked to do by Parks Department in New York was advise how the monument would perform under different load states. So we had to do a structural stress analysis. And being that it's a masonry structure, there's no metal, it's all just compression and mortar joints. It's stone and brick, essentially. We wanted to accurately model the transitions in the masonry, thicknesses, the vaults, and so forth. So we really wanted to, if you have an experience making 3D analysis models out of finite elements, it's laborious. And for us, we wanted to try and optimize that process. And one thing Lara's been doing for a while is trying to optimize 3D workflows. We deal a lot with our other types of work with complex geometries, and so automation or coding and scripting processes is a part of what we do. So here we had good CAD drawings because we had pretty good original drawings, hand-drawn, beautiful hand-drawn drawings. And so that was a great basis for TPAS and for the the other work that was done. But to create a 3D model, we needed to be in 3D. And actually, originally we explored using 3D AutoCAD, taking the 2D and making it into 3D. We found that a little cumbersome to then translate, because ultimately what we're doing is translating geometry from one platform to a structural analysis platform. And so we decided that to use the geometry information we had in 2D CAD, let's generate a Rhino model. Rhino, if you don't know, is a 3D geometry software platform. It's pretty easy to use. It's used a lot in the architectural design field. We're very familiar with it. So we generated a Rhino model of the monument, as you see there. I wanted to go from Rhino into SAP, which is a Structural Analysis Finite Element Program. To do that, you can't just copy it. We actually had to take each part of the geometry and translate it through coding. We use Grasshopper a lot. Grasshopper is a graphical, it's what's known as a graphical algorithm editor. It's a graphical platform, contains lots of subroutines or algorithms in it, and then you combine them. And so you can write code in it as well. And so we have a bunch of these custom built already that we use a lot, and we made more for this project. So we essentially took different parts of the Rhino geometry, which wasn't necessarily complete. We informed it further. For instance, we knew what the base of the monument was like, but there was also all these voids in there, so we had to kind of add that in. So taking each component and using programming, we were able to build finite elements in 3D that we felt were accurate enough to capture all the different stress flows. The monument is largely symmetrical, but there's the entrance. So there's niches, there's voids. And at the end of the day, we wanted to feel comfortable about stress concentrations and that there wouldn't be areas that would have the stress that we were overlooking. So all the vaults were created separately. There's a base vault, a brick. There's 3 Guastavino vaults. There's 2 Guastavino vaults. One's the Oculus, and then there's a vault on the very top as well. All those were created together to create a finite element model that we can then do various stress analyses, as you see. And from that, we can then understand gravity loads, which, as is expected, the monument behaves very well, and that correlates with what we observed. Most of the deterioration in the monument is actually due to environmental factors. We were also able to talk to Parks Department about how it might perform in a expected code earthquake. And so we were able to find good results and look at stress concentrations throughout. So we're able to generate plots like this. So in terms of scale of effort, that was about maybe a 2-week effort to do. And sometimes that can take a whole lot more. Once we did all that, went through the process with vertical axis, with TPAS, we started thinking internally about what more could we do next time around. And that's part of our culture, because we have a lot of programmers, we have people that are doing VR, we have people that are thinking about pushing things in terms of technology. But to be clear, our use of technology is mainly on the software and programming side. We're not doing the physical technology, like the scanning and the drone use. So we want to work with partners. And one thing that was very interesting for us was that on the exterior we had TPAS, and that was hands-on and digitally annotated. On the interior we had a drone and it created all these visuals. Essentially, we had video and we had still photography. And then what we did is look at those on the computer screen and then annotate in CAD our drawings. And so we were debating, well, how can we make that process a little easier for us? And so we've been playing around with coding that would essentially allow us to using differences in light and darkness on a video image or a still photographic image, identify those contrasts, and then try to understand which of those are cracks. And we have people that are familiar with machine learning, and so we started a process where you can first, with input, trace over a crack, a spall, whatever, erosion area, and then teach the code that that's what that is. And it's a process that works upon itself. And we're hopeful that maybe in the future, when you get projects of sufficient scale and we can build this as a custom algorithm, that we can do that. So that instead of someone being at the screen all the time, it could be someone at the screen watching the process, updating the process, and teaching it. Now, it's a bit of a tricky debate because there's nothing that replaces hands-on. So what was done outside in TPAS in many ways is similar because you had digital annotation and you had the visual. So we think it's appropriate for places where you really can't get the hands-on as easy, and yet you still want to optimize your time frame. So these are just examples that we've done after the fact that hold some promise for us. Basically, what we're finding is when you're willing to do coding or programming, possibilities are endless. We've been talking about a lot of data. It's really how you use that data and manipulate it from platform to platform. And the only way to really do that is to do your own programming. Now, to take it a step further, and the reason I show this up here is because a couple years ago, people at Lara became very interested in virtual reality. A gaming background, whatnot, they became interested in using Oculus and HTC Vive and Samsung and so forth. And there's been a growing trend in the architectural design industry to use that to help visualize things. But we've been thinking about how can it help the design process. And so I challenge those people is, well, how can it help what we're doing in restoration work? And so what we did in Soldiers and Sailors is we flew a drone and we took video, but we didn't take 360 video. But you can do that now. And so if you, and these are possibilities now. If you can do a drone, take the 360 video, take that, you have it in 3D space, and then use a virtual reality environment, you could potentially, see if I can run this now, work in the 3D environment, which we feel is intuitively a better environment to be in. Once you get used to the headsets and you have your systems working, it's actually quite nice. And so instead of someone annotating on the screen, and this is whether you're using machine learning or some type of enhanced software or not, you could be in the space and get a better perception. That's the one thing about video and photography, is that it's still a 2D perception on the screen. But when you're in a VR space, you get a sense of depth, which is also important. So ultimately, this is really not to supplant the hands-on, but to sort of get closer to that feel. So for the work in the interior, we never got to go up there. And the exterior we did. And I think the difference between the two can be telling in some projects. There's nothing going to replace the hands-on, but these are strategies for getting closer to that. With that, that's our presentation. Thank you.